SSL, the Secure Socket Layer. Why do we need it? How does it work? Well, let's start. Alright guys, SSL protocol uses Public Key Encryption Method for encrypted data. Public Key Encryption. So, how this method works? Let's look at this firstly. In this method, we use two keys. The first one is public key. As you can see, my drawing skill is amazing, right? And the second one is private key. Cool. As I said, we have two keys. If I use public key to encrypt some data, then I have to use private key to decrypt that data again. Or if I use private key to encrypt some data, then I must use the public key to decrypt that data. Suppose we have a data called data A, 0101. We can encrypt this data A by using our beautiful public key. And now we have an encrypted data, right? Let's call it data B. Alright guys, what I'm gonna do with this data B? If I want to decrypt the data B, then I must use our private key. Once we decrypt it, we have our data A. Well, let's draw the other situation as well. But change the color first. Let's suppose we have a data called data X. Okay. I want to encrypt this data with our private key. And we have our amazing encrypted data, data Z. Again guys, if I want to decrypt the data Z, then I have to use the public key. When we decrypted data Z, then we have our beautiful data X again. Alright guys, I hope everyone understood this part. So, how the client and server use this public key encryption method? Let's look at this. Well, we must have a server and client, right? And here our beautiful server, and this will be the client. Okay, I'm gonna give the name. This is client and the server. Nice. As I said before, we have two keys. What was that? The public key and the other one, the private key. Okay. First, our client send a GET request to the server. Request GET. He says, hey buddy, let's make a communication, and the server responds back with the public key. Let's write public key. From now on, the client will encrypt any data with this public key before sending it to the server. And once the server gets encrypted data, it will decrypt this data with the private key. And the server will encrypt all data with the private key before responds back to the server. But wait guys, there is a problem here. Client doesn't know if this public key has came from the server. So what could happen in this situation? Let's say there is a bad guy in our network. I'm gonna call it bad guy. This is our bad guy. And I'm gonna remove this stuff. Our very bad guy has its own public and private keys. Let's draw them. Nice. I'm gonna apply the same scenario. Our beautiful little client wants to communicate with the server and it sends a GET request. But this bad guy captured the GET request before the server get it. And what is bad guy gonna do? He responds back its own public key. Let's draw it. Now, our little cute client has bad guy's public key. Of course, the client thinks this public key has came from the server, because bad guy shows itself as a server. And from now on, the client encrypts the data with the bad guy's public key and send it forward. And the dangerous communication goes on. As you can see, guys, this public key encryption method has a serious vulnerability. So what can we do to fix this vulnerability and save the ass? Let's jump into SSL and learn how does it work. Now, let's look at how to fix that dangerous issue with SSL. Server must have an SSL certificate before communicate with any client. And that SSL certificate must be signed by someone who our client can trust it. In this case, we are gonna get certificate authority to sign our SSL certificate. Let's call it as certificate authority CA. Okay, now our server will communicate with this certificate authority. It says, hey bro, take my public key and other information such as domain name, email, and sign it please. By the way, the certificate authority has its own public and private key. Let's draw them as well. This is public key. And here is private key. Cool. When certificate authority gets these informations from the server, it uses its own private key to encrypt, or in other words, sign it. After that, it generates a certificate. As you may guess, our beautiful SSL certificate. In this SSL certificate, there are some informations about server, such as public key, domain name, email, etc. And the SSL certificate also has a signature of certificate authority. And this is the signature. With this SSL certificate, the server sends some other certificates. Middle certificate and root certificate. What we are gonna do with these two certificates? Middle certificate has certificate authority's public key. The client will use this public key to decrypt the SSL signature to validate the server. Let's draw the public key. It has the public key. The root certificate has a self-signed signature. The client will use this self-signed signature to validate the certificate authority. Of course, it must be a known certificate authority, right? Let's play this scenario step by step. Certificate authority sends all these three certificates to the server. The client sends a GET request to the server. Server says, hey buddy, wait. First get these certificates and validate all the stuff. It responds back the three certificates to the client. Let's write root, middle, SSL. Okay guys, every operating system has a signature list. Let's call it trust list. In this list, there are some certificate authorities' signatures. Every operating system has this list. Once the client gets a response, first of all, it gets the root certificate signature to check if it exists in the trust list. If it doesn't exist in that list, then the client thinks the certificate authority may be a bad guy and client doesn't trust it. If that signature exists in the trust list, then client says, hey, you are a good boy, I know you. And client validates the certificate authority as a trusted one. Then the client gets the certificate authority's public key from the middle certificate and it decrypts the signature of SSL certificate. After decryption signature, the client compared the decrypted signature with the other SSL informations. If both data is the same, then the client knows this SSL certificate came from the right server and it trusts the server. After trust the server, the client gets the public key from the SSL certificate to decrypt all data before sending to the server. And the communication between client and server will be secure. In this scenario, if there is a bad guy in our network, he can't change the SSL certificate info formally without certificate authority's private key. Because when the client decrypts the signature of SSL, then it will know if the information in the SSL has been changed or not. Alright guys, this was how SSL works. See you in the next video. Peace.